Well, hello folks. Today we're going to go ahead and make our slot car rear wheel, like the one shown here. You should have a set of drawings that looks like this. It has the dimensions for our rear wheel. When we take a look at our drawing, we can see a couple things. We're provided with multiple views of the drawing, or of the object. Here's our pictorial view showing the finished rear wheel. Here is the front view showing what the object would look like if you're looking straight on it to the full circular profile. Here's the top view, and over here you can see a section view. This is what the wheel would look like if you cut it away. You sliced it along line CC right there, and we're standing here looking at that cutaway view. You'll notice this drawing also includes a detail view, which gives us some dimensions on the thickness of the part, and that's been cut away from section right here. So you can see the circle, a circular arrow with the letter G in it, shows over here. It circles this area, and then detail G has a different scale than the original drawing, which is 4:1. The original drawing scale is 2:1, so this is twice as big as this over here. We can use this information to build our wheel. We're going to do this wheel as a revolution, as if you were putting it on a lathe and rotating it and cutting it. We're going to sketch this section I've just zoomed in on here. We'll sketch this horizontal line, and then we'll sketch this profile as shown here in the cross-section view. And we'll revolve that to get the full round component as shown up here. Let's go over to our model space and take a look at what we've got. Here's the final product. We're going to go ahead and create a sketch on the front plane. I already have one started, so we'll take a look at that. And I'll have the example that I've already created there, and we'll walk through creating that. Of course, when you first come in here, your planes will be turned on. You can toggle those on and off by tapping the letter P on the keyboard. That's the quickest and easiest way to do that. You can also toggle those over here, but I find the letter P on the keyboard to be way faster and easier. I have a line created that goes through the origin. That's going to serve as my revolution axis. You can toggle that back and forth between a solid line and being a construction line by tapping the letter Q on the keyboard or clicking the construction line tool up top. Next thing we're going to do is we're going to draw this profile, and that profile is going to be kind of C-shaped. I'm going to do that using the line tool, and we'll go ahead and right now I'm going to just draw a horizontal line. I'm going to ignore most of the other stuff around. Now you can see this is a neat trick. You can switch back and forth between straight lines and tangent arcs after you've created your first line, just by bringing your mouse back to the end point of the line, as you can see I'm doing here. Bring it back, and then now a tangent arc. Bring it back. It wants to create a straight line. So I'm going to create tangent arcs, and I'm going to draw a quarter line. There you go. Just moving the mouse along, transitioning between creating a line and an arc. And let's get that line up. Okay, now at this point, I just have an outline profile, and this outline is not fixed. It's got lots of squishy movements that I don't really like. So what I'm just going to do is go around the sketch and applying vertical and horizontal constraints to things to get them to line up the way I want them to. So first of all, I'm going to start with horizontal, making sure that all the lines that I want to have horizontally constrained are. So those are all my horizontal lines. I also want my endpoints of my arcs to line up with their center points. So here, here. Be careful to only click the things that you want to be horizontally aligned with each other. You click accidentally apply that constraint somewhere else, you're not going to like it. Now you can see this doesn't quite look right. So I want this center point to be aligned with that end point. So we're switched to the vertical constraint now. I'm going to apply a vertical constraint here, 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 and here, and here, and here. Make sure all of my lines that I drew vertically stay vertical. Apply a vertical constraint to all those. And now this system should move naturally in the nice smooth transitions that we're looking for. Like that. Now we're where we want to be. Let me drag this over so that it lines up with the I want this edge of my line, this outer rightmost line, to be vertically constrained. So I'm going to click this endpoint and that origin so they line up with each other. This will help me verify that I've completed the drawing so that all my lines will turn black when I'm done. And so far we haven't applied any dimensions, so we need to go back to our drawing and see what dimensions we need. As is typically the case with circles and full round objects, we're given measurements in diameter. So we have a center hole at 185 thousandths and an outer diameter at 1.2 inches. Those are diameters, and that is conventional for drawing circles. But we're working with half a circle, so we'll need radii. We dimension this. I'm going to go ahead and create the dimension for the outermost part, the biggest dimension first, and that was 1.2 inches is the outer diameter. But again, we need a radius, so I'm just going to hit the divided by 2 before I hit the enter key. Tap the enter key, and you can see that kind of made a little weird thing happen down here. No big deal. I'm just going to grab this and pull it back up where it belongs. And check my dimension or my drawing again. Now the inner hole was 185 thousandths. So dimension from the center to there at 185 thousandths, 0.185. And again, that's the diameter, so divided by 2 to get the radius. And now let's see what else. The overall thickness is 4/10 of an inch, 0.4 inches. So let's go ahead and give a dimension to the overall width. So from the farthest right to the farthest left, that was 0.4. I want this line and that line to line up with each other, so I'll tap the V key and make this point and that point line up with each other. The escape key. That pushed this inner part outside. That's no big deal. I'm just going to drag it to the left, get it back closer where I want. Getting closer. So that's all the dimensions from the top view. That's all the dimensions from the front view. Let's take a look at our section views and our details. Detail view gives us something interesting, that the thickness of our parts is 60 thousandths. So let's go ahead and apply that thickness. That means the length of this line right here is 60 thousandths, 0.060. And it showed both of them, everything being 60 thousandths. So that means this is going to be equal to that. So I can apply an equal constraint from the drop-down menu on our constraints menu, or tap the E on the keyboard and click and release here, click and release here. Those are now equal. This dimension here was supposed to be 60 thousandths as well. According to our drawing, yep, sure, right there, 60 thousandths. So dimension from here to here is 60 thousandths. So it's decimal point 060. All right. And the last thing is to dimension these radii. Get a little closer to where we wanted to be before we apply dimension. And the outer dimension, outer radii are 1/10 of an inch, 0.1, and the inner are 50 thousandths. So dimension 0.1 and dimension at 0.05. And again, the upper and the lower are equal, so we should use the equal constraint. So tap the upper and the lower, tap the upper and the lower. See, everything has turned black. That means this thing is fully constrained. It should be correct. I'll turn my sketch back on. And now it's time to revolve that. So hit the revolve button. It's going to ask us for the face regions to revolve. Click the release on that area. It's asking for the revolve axis. So I'll click the axis that I want to revolve around. And you can see that creates the full revolution. My new part has been added. This is called part 2. I'm going to rename my part. Yours will probably be yours will be part 1. So I'm going to rename this wheel, rear wheel. And then I'm going to apply a material to it so that we can check to see if we got this right. So right click, assign material, and according to our drawing, the material is PLA plastic, and we should be using 7 thousandths of a pound. So let's check. PLA, scroll till we find PLA, getting check, and then clicking on our weights and measures button over here, display mass properties, click on the object, and 0.007 pounds. That's what our drawing said. That means we got it right. Awesome. So if you got it, congratulations. Great work. Good luck. Have fun. And as always, keep being awesome.